The bead is the lip of the tire that fits to a wheel rim. High-tensile steel wires inside the bead pull the tire tightly and uniformly to the rim. These bead wires provide stability so the wheels can start turning. These bronze-coated steel wires are the muscle in the bead of a tire. They're a source of hidden strength that we don't usually think about. But without them, tires wouldn't properly grip the rim, and riding on wheels would be dangerous. Production starts with coils of high-carbon steel. A forklift slides the coils onto metal cones. A worker cuts the ties around the wire. Then the cone moves into an upright position on the carousel. A motorized system uncoils the wire and pulls it up through the cone. At the top, a guide positions the wire to enter a descaler. The device has a revolving sandpaper belt, which smooths and refines the wire. Next, the wire travels through a channel filled with powdered soap, which acts as a dry lubricant. Then the system pulls the wire through a series of dies, each with progressively smaller openings. The process is called drawing because it draws down the diameter of the wire, stretching it longer and thinner. The process reduces the wire's diameter by almost half. A carriage lifts the thinner wire onto a spool that winds it up. The table the spool sits on turns to deliver the wire to the next operation. The spool of wire is one of 40 that now unwind simultaneously at a controlled speed. Large combs keep them separate, so they'll be ready for the next stage of the journey. A trip through a long oven. It's heated to an incredible 1800 degrees. Inside, intense heat recrystallizes the microstructure of the wires. This reduces brittleness. Then spools take up the wires. The wires take a dip in a tank filled with hot water and phosphate solution. A floating foam blanket keeps the solution hot. The phosphate solution and a subsequent rinse lubricate the bead wire for the next process. A second drawing that squeezes the wire even longer and narrower. The holes in a series of dies become progressively narrower to reduce the wire's diameter even further. After each trip through a die, a drum winds up the wire. Each drum turns a little faster than the one before it. That's because longer wires need to be wound up quicker to prevent slack in the system. This final drawing process brings the wire's diameter down to less than 1 millimeter. The bead wires are now at the correct width. Next, the bead wires receive their bronze coating. Bronzing the steel wires allows them to adhere to the tire rubber. After the bronze solution dries, 2 rollers straighten the wires. Then, a spool winds up the bead wire. They produce bead wire in different thicknesses and metal coatings for a variety of tire sizes. They test the wires before they leave the factory. If it can withstand up to 1,500 pounds of force before it breaks, then it's ready to be shipped to the tire factory. Once they're installed in rubber tires, these bead wires will be an important source of strength, doing their part to keep your vehicle moving forward safely.